All right, so what I want to do is show you about like equivalent ratios and rates. Hopefully today in class we managed to get to some practice with using like maybe some models to determine about ratios and rates if they're equivalent, right? Well, sometimes we want to just determine when the two ratios or rates are equivalent to each other. So what we do is we write them as what's called a proportion. And the proportion is written down here, you'll see this. It's an equation that states that two ratios are equal, and you write it simply by putting an equal sign between the two equivalent ratios. So this one is like 2 white daisies to 5 total equals 8 white daisies, and then you're like, well, the box means like how many would there be total? And then you use the equivalent ratios or ratios to represent the same part-to-part relationship or the same part-to-whole relationship. It's pretty much the same thing when you look at this as finding an equivalent fraction. You have total white daisies is 2, and the total daisies is 5, so if you do 2, how do you get from 2 to 8? Oh, well, I do times 4. Okay, well then what do I do to 5? Times 4, you get 20, so 8. If I wanted 8 white daisies, I'd have 20 total daisies. In this example, when you have white to total daisies, which is a part-to-whole relationship. Now when we do this, you're going to rewrite a ratio, and with greater numbers like this one, before we went like 5, we went up and went up, it's called scaling up. Scaling up means you multiply the numerator and denominator by the same factor. You can also scale down by dividing by the same factor. So scaling up is when you end up with an equivalent ratio, or kind of looks like a fraction, that gets bigger. So in this case, we have total daisies to white daisies, just the same ratio, just flipped, and 8 white daisies, so you multiply by 4. This is scaling up because both of the numbers are getting larger and you're multiplying. If you scale down, you're dividing. Here are some sample problems. If you feel like you could potentially handle these, feel free to take a look at it, pause the video now, solve them, and then watch me talk about as I solve these. So the daisy smile bouquets are sold in the ratio of 2 white daisies for every 3 orange daisies. Scale up each ratio, determine the unknown quantity of daisies, explain how you calculated your answer. So this explain, you can explain this with mathematics. I'll explain it by talking about it in addition to the mathematics. So you have 2 white to 3 orange. And it says over here, how many white daisies for 21 orange? So I think, how do I get from 3 to 21? And I can basically do 21 divided by 3, 7 if you hadn't already thought of that. So then I know it's times 7. So then I just do the same on the top, 2 times 7. 2 times 7 equals 14. So it would be 14 white daisies and 21 orange daisies. Okay, next one. You have 2 white daisies to 3 orange daisies, so it's the exact same ratio. This case it says 33 orange daisies, so I do 33 divided by 3, that's 11, so it's times 11. And then you do 2 times 11, and that equals, oops, that was not correct. 2 times 11 equals 22. Sometimes slowing down to write it when you already know the answer in your head can be a little bit tricky. But so we end up with 22 white daisies to 33 orange daisies. Pretty straightforward so far. A couple more examples here. Feel free, again, if you're feeling comfortable with this now, pause the video, try them, then check your work. So hopefully you may have paused and tried some of these. So this one's going the other way. It gives us the white daisies. So 12 divided by 2 would be 6, so it's going to be times 6. So 3 times 6 would be 12 white daisies to 18. 3 times 6 is 18 orange daisies. And then down here, so we have to work with the same ratio again. It gives us the white daisies. 24 divided by 2 this time is 12. So it's times 12. So you do 3 times 12. And 3 times 12 is 36. 24 white daisies to 36 orange daisies. So talk a little about scaling down. Didn't give any examples of that. Focus here is scaling up and coming up with equivalent ratios in more of a mathematical sense versus the practice we did in class today.